David Smith here with one more Flip Classroom math video in the rain. 3 tips before we start. First, you can speed up or slow down the playback if that helps you digest the content. Second, you can pause the video anytime and catch up with your notes. Lastly, you could turn on the captions and watch my words go by on the bottom of the screen.
Hello.
Today's topic is composite function. And a composite is something that's built of 2 or more things. So in technology, we have composite materials that are used in like fancy applications like fancy bike frames or spaceships, rocket ships, things like that. In math, we have composite functions, which are basically just functions that are built of 2 or more individual functions. So let's take a look at that. So here's our definition, a function that is built from 2 or more functions. And okay, let's start this by looking at 2 functions. Here we go. We've got f of x is x squared, and we've got g of x is x plus 2. So here's some notation coming at you. We could write f of g of x. So what we're doing is we're just saying we're going to take g of x, but whatever this is, we're going to also run it through f of x. Okay? So it's kind of like we could take a number, we could put it in here, get our result, then take that result and put it in here and get a final result, and that would be f of g of x. Now in this case, we're going to do the general formula rather than actually plug numbers in for x. So what we're going to get here is we're going to put our g of x in there. So that's our x plus 2. And then we have to do f of x to that. So we basically take the g of x rule and we stick it in where the x is in the f of x rule, which means we're just going to square that. Okay? So f of g of x would be x plus 2 squared. So we could do it the other way as well. We could do g of f of x. And all that means is, well, whatever number we have, we'd plug it into this one, the f of x, we'd square that number, and then we'd take that result and we'd stick it into the g of x function, and we just basically add 2 to it. So now, if we want to write the general rule for g of f of x, the first thing we do is we put in our f of x, that's x squared, and then we do what g of x would do, we take this result and we put it in where x is, so that's just going to be x squared plus 2. Okay? So 2 different functions. In fact, there's an important rule here that we're going to say f of g of x is not equal to g of f of x. Now that's not always going to be the case, but in this case, it most certainly is. All right, let's do a couple more examples. If you're feeling bold, go ahead and pause the video and do f of g of x. So here's my f of x, 6x minus 1, and my g of x is x squared plus 1. So pause the video and come up with the function that would be for this one, f of g of x. Okay, so here's the thing. We start with our g of x, that's what's inside, and that's x squared plus 1. Now what do? We take this result, whatever this would be, which is now represented just by the x squared plus 1, and we put it in where the x is in here. So what we would do is we would go here, 6x. So that's 6x, but instead of x, we have our x squared plus 1. So we have 6 times x squared plus 1, and then we have our minus 1. Now, many times in these, you're going to want to simplify them on down to simplest form. So let's do that. This is going to be distributive property 6x squared plus 6 minus 1, which is going to give us 6x squared plus 5. So that 6x squared plus 5 is f of g of x. Okay, cool. Now I want you to pause the video and do the other one. G of f of x. Go ahead and put your thinking cap on and do this one. It's the same idea, but now you're going to start with f of x and put g of x around that. All right, let's see how you did. So here I took my f of x, which is 6x minus 1. I put that there, and now I'm going to take that 6x minus 1 and put it in where x is here. So that's why I square it, and then I add that 1. Now, go ahead and pause the video. I'm going to want you to simplify that on down as well. All right, so all I did is I squared this binomial, as indicated by the squared there, and added 1 to the result, which gave me 36x squared minus 12x plus 2. Now, this is review. We've done this before. You'll want to polish off those skills in case you have trouble getting from here to there. All right, now let's play around with actually putting numbers into our composite functions and calculating the resulting y value. So what we're doing here is I have an f of x, which is 3x minus 5. I have a g of x, which is 2x squared. And now I'm asking you to find f of g of 5. Now what that means is we're going to put our 5 into g of x, and then whatever that is, we're going to do f of x to it, and that's going to be the result. So if you're feeling confident, go ahead and pause the video right now and do that. Okay, now you could do this problem just by taking the 5, doing this math, taking that number, the result of that, and then come over here and plug it in for x, and then do that math to get your result. I like to do it a little bit more elegantly by plugging all my stuff in first, and then doing my calculation. So this part right here, that's the g of x. I put my 5 in for x, it's 5 squared, and then times 2. So that's g of x. And then what I've done here is that g of x is now in here for x in my f of x function. So I have 3 times g of x minus 5. That's the minus 5 from there. And now I can do my number crunching. 5 squared is 25, times 2 is 50, times 3 is 150, minus 5 is 145. So f of g of 5 with these two functions is 145. Now I want you to do it the other way. I want you to do g of f of 5. See what you get with that. Go ahead and pause the video, do that calculation. All right, let's see how you did. So here is my f of x. It's 3x minus 5. My x value is 5, so I'm doing 3 times 5 minus 5. That's this part here. Now I take that result, that's my f of x, and I stick it in for x in g of x. So that's this 2. I'm just multiplying my f of x by 2, but I'm also squaring it, which comes first. Okay, so now this is a pretty easy calculation to do. 3 times 5, that's 15, minus 5, that's 10. Now I have to do my power first. 10 squared is 100 times 2 gets me all the way out to 200. Now you'll notice that f of g of 5 is not the same as g of f of 5. Here are a couple interesting ones for you. I have my same old not the same ones, but two functions just like before. Although this time f of x is the square root of x plus 3, and g of x is 3 times x squared. But now I'm going to ask a little different question. Notice how this is f of 9. So that means just take 9, put it into f of x, then take that result and put that back into f of x and see what you get. Okay? So f of 9. Pause the video and see if you can set that up. All right, let's see how you did. So what I did is I just took my 9 and put it into my function. So that's this bit right here, root 9 plus 3. Now that result is also going to go back in 4x in the same place in the function. So that's going to put the root on the outside of that and then add this 3 on the very outside. So now root 9 is 3 plus 3 is 6. So we have root 6 under the root sign plus 3. So I just stopped right there. You can get out your calculator and find out what root 6 is and come up with a decimal expansion. But remember, if the book or a test or anywhere you're asked for an exact value, that means leave it as a root. Okay, last one. Now I want you to try g of 4. Now here's your g function. So go ahead and put your 4 in there and see what you get for g of 4. All right, let's see how you did. So here is my 3x squared, that's my g of x. So I put in 3 times 4 squared. Now that result is the first time through the function, so I just have that in the same place again. So it's squared, the result is squared, and it's also multiplied by 3. So reducing that on down, 4 squared is 16 times 3 is 48. So here's my 48. Now I've got the same thing going on again. I'm going to square that 48, multiply it by 3. And no, I didn't do this in my head. I got my calculator out to get 6912 as the final answer. I'm sorry, if I said one last one just a minute ago, I have one more. This is kind of an interesting setup, so I want you to do this one. Here's my f of x, 1/2 x. Here's my g of x, it's 2x. So I want you to find f of g of x. So go ahead and pause the video and do that. I think you have enough that you can do this one pretty quick. Okay, when I do this, here's my g of x, that's 2x, and now I'm going to put my f of x around it, which is just 1/2 x. So the 1/2 goes on the outside. Now, you'll notice when I do 2 times 1/2 to simplify this down, I just get x. Interesting result. We didn't get that before. Try g of f of x. Just see what you get for that. Pause the video and do that math. Guess what? Same result. Here is my f of x. That's my 1/2 x. I've got that inside. Now I stick that into g of x, which means I multiply it by 2. And 2 times 1/2, just like 1/2 times 2, ends up back at x. So what that means is these are special functions. These are the inverse of each other. And what that means is that what one function does, the other function undoes. And we'll explore those a little later, but I wanted to show you this result in case you come across it in any of the exercises. Thanks for watching. Just before you go, make sure to write down any questions that you have so that you can bring them to our next class and get them answered. Also, remember that you can watch the video again if you want to deepen your understanding. Finally, if you enjoyed the video, please click like or subscribe.